Well, hey everyone, welcome back to this video. Fun fact that does not affect you is this is the second time I'll be recording this because the internet crashed while I was converting this file. So I'm gonna try to keep the same pace that allows us to learn, but I feel like I just talked about all of this, so it's kind of crazy in my brain. But hey, that's neither here or there for you. So really, this is about you. This is about learning. You know me, I just wanted to be transparent. So today we're talking about area of larger shapes, and what that really means is like what's going to start happening when our shapes start to get what sometimes we call irregular. And it makes it a little more difficult just to look at it and say, oh, there's my rows and my columns. But of course, before we do that, let us review why the concept of finding the length times the width of something is equal to the area of a rectangle or a square, like why that works. And why that works is because remember, a rectangle or a square is the same thing as an array, right? If I had three groups of three, right? If I had three rows over here and I have three columns over here, well, again, that goes to show that the area, this entire space this thing takes up is 9 units because I'm doing three groups of three. Here's 3, 6, 9. I'm skip counting, and that's all that is skip counting by these rows and columns, right? I could count them all. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or what I could say is like, oh, cool. Well, I know I have 1, 2, 3. And in each one of those threes is another group of three. So that gets me 3 times 3, which is equal to 9 units. Right. And we see that in other ones that maybe aren't so straightforward with 3 and 3. Like if we had a rectangle here and someone said, oh, well, what if it was 4 and 3? Well, I could model that, right? I could boom, boom, boom. So there's 4 columns and then 1, 2, 3 rows. And again, I could count my squares, but the reality is I know I have 1 column, 2 columns, 3 columns, and 4 columns. And each one of those columns has 3 in it, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which again is skip counting 3, 6, 9, 12. Skip counting by threes 4 times to get me 12 units. So what's important about area is that we have these perfect arrays to help us do it. We have these exact same distances on a coordinate plane between one corner and the next, and I can just measure those by the units and it's all the same, right? The opposite sides are all the same. If it's 4 units over here, well, it's 4 units over here. And if it's 3 units over here, well, it's 3 units over here. And that's what really works. That's why we can use this multiplication shortcut. But not always the case, right? Because if I look at this right here, I actually don't have this perfect rows and columns because this part only goes from here to here, but down here, it goes from here to here. So this distance between points isn't a perfect same amount of columns. In fact, over here, I only have 4 columns, but across this whole bottom, I actually have 24 columns. So like we can't just grab numbers and multiply because well, it's not all the same. It's not an equal distribution of 3 rows of 2, or in this case, I actually don't have 4 columns of 12 because it cuts off right here. It ends. So we can't just go straight to, oh, boom. Well, if I just had rectangles and squares, life is easy. Multiply my length times my width and I'm done. Which brings me to this. You're right. I don't have squares or rectangles, but what if I did? What if I did? And that is exactly what we're going to do for our first step to solve these. Actually, the first thing I actually want to do is I want to create arrays. I want to find rectangles and squares in here. And by create, I don't mean just like go draw your own and call it a day. What I mean is if I look at here, I actually could In fact, here, I like this. If I started here and went down here and continued, well, look what I did here. That's a rectangle. In fact, that's a rectangle that I'm gonna shade in this way. I'm gonna call this rectangle number 1. And by doing that, look what happened over here. This point from here to here, here to here, here to here, and here to here, actually creates a second rectangle. Look, so excited about rectangles right now. And this is rectangle 2. So I actually do have perfect arrays in this case. They're just kind of stuck together. And what I could really think about is how I've separated them by drawing this line right here, right? That creates this rectangle and it creates this rectangle, rectangle 1 and rectangle 2. Great. Well, then if that's the case, then all I need to do now is find my areas, right? So that's my second step. I'm going to find the area of each rectangle. So if I think about rectangle 2, I'll focus on 2 to begin with. What I realize is that I do know my columns, right? I have 20 columns. So I'm going to take 20 columns and I'm going to multiply that by the 6 rows that I have. And let's see, 6 times 2 is 12. And then that's 10 times bigger. So that's 120. So I have, centimeters squared. So this rectangle 2 has an area of 120 centimeters squared. 120 centimeters squared. So let's go over to rectangle 1 and do the same thing. Maybe I'll change colors this time. Let's see what would pop out. Maybe some blue. So over here, I see that I have this rectangle that has a column of 4. So if I want the area, I'm going to take 4. And then, oh, well, it's not 6 because 6 is only from here to here. That's not the whole thing. So I don't need to use 6 here. Where would my rows be? Oh, my rows are over here because from here to here, which is the whole thing, is 12. So 4 times 12. Let's see, 4 times 10 is 40. And then 4 times 2 is 8. So my area here would be 48 centimeters squared. Okay, so again, I have these 2 pieces. I guess if I need to find the area of all of it, it would make sense for me to add these pieces together. And that is actually what I'll do. Step 3, we're going to add our pieces or our parts. I don't know, however you want to call it. So if I take the area of rectangle 1 here, which was 48 centimeters squared, and I add that to the 120 centimeters squared that was rectangle number 2, I'm going to get 168 centimeters squared. And that would actually then be the area of this entire thing that I will now oddly shade in pink. So this whole thing, right? The whole thing, these 2 abnormal shapes that I actually found arrays in and other rectangles gets me 168 centimeters squared. Wow. Okay, that's pretty cool. So let's practice that again. Let's try out another one with this, right? Again, thinking about these steps, like find or create arrays in there. Maybe the term is find. Oops. Maybe we want to say find arrays instead of create, like they're in there. We're not really making them. We're just finding them. And then we would find the area and then we would add the pieces. So let's try another one. Sometimes there's ones that are a little more difficult. They might be something like this, where they have like little bits and pieces cut around, but that's okay. That got sloppy, right? And I don't know, let's play around with some measurements here. Maybe we don't know this one. Along the bottom here, what did we do last time? Centimeters? Let's do millimeters this time. So let's see, across the bottom here, we'll call this 8 millimeters. And the side over here, the side's going to be 6 millimeters. And let's see here. Sorry, I'm just trying to think. This is tricky already. So let's call this 3 millimeters. I just need to get on top of things here. And let's call this 2 millimeters. And let's call this one 4. No, that's 3. Let's call that one 3 as well. This isn't going to really show scale because mathematically that means this is 2 millimeters, which is actually longer than that. That's kind of weird. And then that means make this one. Oh, I don't like any. See, this is what I do, and now I have to make it up. I had all these other ones planned. Let's get rid of this. Those numbers were ridiculous. I don't even like this shape. Let's do it like this. Let's go ahead and make it more equal, because that's really what we're gonna find. I don't know why I decided to get all crazy. Let's go like this. Okay, so let's get back to the drawing board and let's make our numbers a little bit better. I said millimeters, that's fine, but honestly we probably need bigger, larger numbers. So like maybe this is 12 millimeters, and you know what, this is 12 millimeters, which makes this 12 millimeters, but maybe we don't know this one, but we do know that this is 5 millimeters, and so is this one. And we do know that this is 4 millimeters, and this is 4 millimeters. Okay, great. Now let's play the game. So sorry, I just like that last one. I was like, what am I doing? We're making this more complicated. We're not going to see that big of a complicated problem. So the first thing we're going to do is we're going to find arrays. Great. So let's find those arrays. Oh, wait. Gosh, I guess I can't because I don't know what this is. But I can find out what it is. So look here. We know that from here to here is 12, meaning that actually from here to here, right, this whole thing would also be 12. And I know parts of this whole thing. I'm gonna do like a little dot line here. Actually, I'll do the whole like this, right? Because I know from here to here is 4. It says it right here. And I know that from here to here is 4 because opposite sides are equal in measurement, right? This is the same thing as here to here. Which means my missing piece, if the whole thing is 12, and I do know that I've used 4 of it here, I'm using 8, and I used 4 of it here. Oh, well, that makes this missing part right here 4 millimeters. Okay, well, let's get rid of some of this stuff because that got a little messy. Okay, get rid of you. See you later. You're gone. Okay, great. So now I've done that. So now I can find my arrays. So where do I want to draw and kind of create some rectangles? Well, what if I went, well, let's see, let's go this. Oh no, let's not do that. There we go. Let's go this way. I think if I drew a line here, I'd actually end up creating 1, 2, and 3 different rectangles, right? Do you see where that is? Like, again, we have this one right here. And then we have this one right here. And then we have this one right here. And so now in this case, instead of 2, I just need to find, which brings me to step 2, we need to find the area of all the parts. So find areas, right? Computate, do the math. So let's see, let's start with 1 here. What do we know about 1? We know that it's 12 long. That works. So let's see, 1 is going to be 5 or 5, what? You know, it's, oh my goodness, what is going on here? This is what I get for double time. My brain's fried. So we have 12 times, and then we got to figure out this distance here. And what we know is the whole thing, right? From here to here, that's 12. And we know that from here to here, this part right here is 5 millimeters because that's 5 millimeters, right? This piece right here. So the difference between 12 and 5 is 7. So that means that this section right here is 7 millimeters. So to find rectangle 1, I got to take my 12 times 7. So let's see, 10 times 7 is 70. And then 2 times 7 is 14. So that's 84 millimeters squared. Let's put that over here, 84 millimeters squared. So that's the area of rectangle 1, which is the green one. Okay, and then let's find the area of rectangle 2, which is this light blue one over here. Promise I'm drawing. And we know we have columns of 4 times rows of 5. So that one works out a lot easier for us. 2 is 4 times 5. So that's 20 millimeters squared. And actually, look at this. It's rectangle 3 is the same thing. Right? Same dimensions. So I didn't have to do much computation there. So now if I want to know the area of the whole thing, I'm just going to add all my parts. And this time I have 3 parts. If you remember in the last one, we had 2, right? We had 1 and 2. Oh, look at that. That's like a crazy art piece. And in this case, then we have 3 parts we're going to add together. We have the area, the green area, which is 84 millimeters, plus this section over here, which is 20 millimeters. And then it's over here, that other section is also 20 millimeters. So that gets me 124. So my area of this entire shape is 124 millimeters squared. Okay, so that's a lot. I'm gonna leave it at that because I feel like if we do another one, that video might go on forever. And then I also might like draw some crazy shape and have to erase and start over. But you know, if we think about what we're doing here, right? We understand area. We know that area needs to be a rectangle or a square. So when presented with problems like this, where we actually don't have just rectangles, right? Maybe I should draw one, right? If we represented like something like this, where we actually don't have just a straight up rectangle, well, we can use our math to understand that if we find the arrays, if we find the rectangles or the squares in here, right? Like maybe here I draw this, then all I have to do is find the area of one section, find area, and the area of a second section. And then if I add those together, I'm going to have my final answer, right? We'll call this A, we'll call this B. If I add the areas of A and B together, then I have the area of the entire shape. And so that's the work we're doing. I apologize for this video. I know that it was a little haphazard. It's because I had to do it again, and I apologize, but I hope some of this makes sense. And if not, you know, the perfect place to ask clarifying questions, and that would be in the class. So we want to thank you for your time. You are wonderful. You are great. And we will see you next time.